Hello, Math 2 students. Today we're here to find out how to find the greatest common factor. And we're going to start out with 20 and 30. Sometimes students like to find the greatest common factor by saying this. What is the biggest number that goes into both numbers evenly? And so if we think about this, 20 can be 1 times 20. Those are two factors. It can be 2 times 10. Those are two more factors. Or it can be 4 times 5. Those are two more factors of 20. For 30, we could have 1 times 30, 2 times 15, or 3 times 10. So when we're looking for the greatest common factor, we're looking for something that is in common on both lists. So we have 1 on this list and 1 on that list. Those are common factors. We have a 2 on this list and a 2 on that list. Those are common factors. We have a 4 on this list, but no 4 there. That's not a common factor. 5, not a common factor. 10, there's a 10 on this list and there's a 10 on that list. 20, there's no 20 over here. There's no 15 over here, and there's no 30 over there. So the three common factors are 1, 2, and 10. Those are the common factors. Now we want the greatest common factor. So between 1, 2, and 10, which of those numbers is the greatest? It is 10. So the greatest common factor, which a lot of times is called the G.C.F. of 20 and 30 is 10. Now, some students, especially with bigger numbers, they struggle to find out what is the biggest number that goes into both numbers evenly. Some people can just look and they know right away that the answer is going to be 10. Other students struggle with that. So another method that you can use to find the greatest common factor is to use a factor tree. So if I take 20 and 30 and I make a factor tree for each, this is 2 times 10 and 10 is 2 times 5. So for 20, the prime factorization is 2 times 2 times 5. Now if I make a factor tree for 30, that's going to be 2 times 15, and 15 is 3 times 5. So the prime factorization for 30 is 2 times 3 times 5. So when you look at these prime factorizations, you try to identify which prime factors are on both lists. So we have a 2 on both lists and a 5 on both lists. So by using this method with a factor tree, finding the prime factorizations, our greatest common factor is 2 times 5, or 10. On this problem, we're going to find the greatest common factor of these two algebraic expressions. These are both monomials, 18x to the third, y to the second, 40x, y to the fourth, and we are going to find the greatest common factor. Some students can look at 18 and 40, and they know the greatest common factor is 2. 2 is the biggest number that goes into both of them evenly. But many students struggle with that, so I'm going to take my 18 and make it 2 times 9, which is 3 times 3. And I'm going to take my 40, which is 2 times 20, which is 2 times 10, which is 2 times 5. So now, for my 18x to the third y squared, my prime factorization is 2 times 3 times 3 times x times x times x times y times y. So x times x times x is x to the third. Y times y is y squared. So 2 times 3 times 3 times x times x times x times y is 18x to the third, y to the second. When I go to my 40x y to the fourth, that's going to be 2 times 2 times 2 times 5. So 2 times 2 times 2 times 5 times x times y times y times y times y. So here's the prime factorization of this monomial. And here's the prime factorization of that monomial. Now, let's see what they have in common. So here we have 2's in common. There's no 3's, so they both have at least 1 2. But there's no more 2's up here to be in common, and there's no 3's down there to be in common. The 5 is not in common because there's no 5 on the top. There is 1 x in common, and there is 2 y's in common. So these both have at least 1 x, and these both have at least 2 y's. So now my greatest common factor will be two x y to the second. Some students would just look at this problem and without writing all of this out, they would look at the 18 and the 40 and they would say the biggest number that goes into 18 and 40 evenly is 2. Then they would say to themselves, they both have at least 1 x. That's why we have 1 x here. And they both have at least 2 y's. That's why we have a y squared there. All right, on this problem, we're going to find the greatest common factor, but we're going to change the terminology a little bit. Now we're going to say that we're taking out the greatest common factor. This is a problem where we're doing the exact opposite of the distributive property. As you'll see by the time that we're done, instead of removing the parentheses by multiplying the outside number by everything in the parentheses like you do when you do the distributive property, we're going to add back in the parentheses by drawing the parentheses and putting the greatest common factor in front of the parentheses. So our first job is to find the greatest common factor. So for 8, we have 2 times 4, which is 2 times 2. And for 24, we have 2 times 12, which is 2 times 6, which is 2 times 3. And so we have 8y squared and 24y. And the prime factorization is, let's see, 2, 2, 2 times y times y. And for 24, the prime factorization is 2 times 2 times 2 times 3 times y. So those are our prime factorizations. Now we have to see what they have in common. So both terms have at least 3 2's, and both terms have at least 1 y. Now, it's also going to be important to see what's left over from the prime factorization. That's going to help us finish the problem. So we're going to turn this problem into a distributive property problem. So we're going to put the greatest common factor on the outside, and then we're going to put the leftover factors on the inside, and we're going to check our answer by doing the distributive property and making sure that our answer comes out to what we have here. So our greatest common factor is 2 times 2 times 2, so that's 8. And we also have a y in common, so we have 8y as our greatest common factor. Now we need to think about 8y times something is 8y squared. Well, it's going to be this leftover y right here. So 8y, which was the greatest common factor, multiplied by the leftover y, gives us our first term, 8y squared. Now we're trying to get our 24y. We're trying to get our second term in our binomial. And we already have 8y, which is all of this stuff. The only thing that's left over is the 3. So if we put a 3 here, now when we do the distributive property, 8y times y is 8y squared, and 8y times 3 is negative 24y. And since this stuff written in black matches this stuff written in blue, we know we've done the problem correctly. We did the distributive property in reverse. we started with what the answer would have been, and we created the distributive property problem with the greatest common factor on the outside and the remaining factors on the inside. On this problem, we're going to solve the equation 3x squared minus 9x equals 0 by using factored form. So we're going to take out the greatest common factor and have parentheses and have a problem that now is in factored form. When the problem is in factored form, we're going to know how to find the solution. So we start out and we take this side of the equation, and in order to find out what values of x will make this side of the equation equal 0, we need to put it in factored form, which means we need to find the greatest common factor. So this is 3 times 1, and this is 3 times 3. So the biggest number that goes into both of them is a 3, but I'm going to go ahead and write it down. So I have 3x squared, and I have 9x. Its prime factorization is 3 times x, and its prime factorization is 3 times 3 times x. So now when we look for common factors, they both have a 3 and they both have at least one x. So our greatest common factor is 3x. So we're going to set up our problem like this. And our greatest common factor again is 3x. And we want to think about how do we do the distributive property so that this product right here comes out to 3x squared. Well, if I'm trying to get 3x squared, that's where this chart is very helpful. I have a leftover x. So my leftover x is going to go right there. And if I'm trying to get 9x, this term right here, what do I multiply 3x by so that the answer comes out to 9x? Well, it's right on the table. It's the part of the factor, part of the prime factorization that we didn't use yet. So that's going to be 3. So if we take this binomial and we take out the greatest common factor, 3x times x is 3x squared, and 3x times negative 3 is negative 9x. We have the problem done correctly. So now we're going to rewrite our equation, but our equation is going to be in factored form. So our equation used to be 3x squared minus 9x equals 0. Now in factored form, our equation is 3x times x minus 3 equals 0. Now we need to find the values of x that will make the left side of the equation equal to the right side of the equation. Well, we already know that here, x needs to equal 3. Because if we can make this set of parentheses 0, anything times 0 will be 0. And from this part, when we have an x in front of our parentheses, we know that we will always have one solution that is 0, because 3 times 0 is 0, and anything times that 0 will be 0. So these are the solutions to our equation.